Welcome back for another video. This video is going to be one of, I believe, I think it's like 6 or 7 videos on 3D milling, and this is the first, of course, of those videos. In this lesson here, we're going to make this part that you see on your screen now. So let's go ahead and get started. First, we're going to start off by drawing this. The first thing we need to do is we need to create a profile of this part. And what we're going to do, since we know that this is kind of like cylindrical, as you can see, it's basically like a half a cylinder. It almost looks like, I call it the rook, because it kind of looks like a rook. What we need to do is create half of this profile around the outside of this part, and then we're going to revolve that out of a solid. Actually, we're going to do a surface. So what I'm going to do here is I'm going to start by creating this top profile. And I'm going to do that right up against the x-axis. Okay, so first thing I'm going to start off with is, and I may do this a little different from your book. Your book uses a little bit different strategy, so I just do this kind of the way that I would do it. And I think that's advantageous because it shows you another way of creating this geometry. All right, so I'm going to start off by creating this here circle. Maybe just create some of these circles. This one here I don't need to create, but I need to create this one, this arc, and I need to create this arc at least. And that'll give me a good starting point to start drawing my lines. All right, so let's move this to the side, and let's take a look at our master cam. So I'm going to draw this first, the right-hand arc up in the upper right-hand corner there. I'm going to select my circle, and I'm going to go ahead and create the center point of that, which would be, let me drag this over one more second here. So I'm going to make my 0 at the edge here, and I'm just going to shift this over this 7/16 dimension. So I'm going to make 0, 0 right here where my cursor is. It just makes things easier for drawing it, and then I can just translate it later. So that's how I'm going to create this thing. Just so if you don't understand how my math's going to work. So we're going to start out by drawing this circle, and we're just going to take 0.375 and subtract, of course, a 1/4 inch, and that's going to give us the center of that circle. And then, of course, this gives us our y-axis. All right, so our first one is going to be 3.5, comma, 0.625. Looks like I got a click in my, I wasn't clicked over. 3.5, comma, 0.625, enter. All right, and I'll enter my diameter of 0.5 because it is a 0.25 radius. And my next one here is saying that it is 0.625 in the x, which is actually the center. So I'm going to say 0.625, comma, and it looks like it's 0.75 to the end, so it's actually 0.5, so we'll say 0.5 in the y, and our diameter is 0.5. Okay, all right, so that gives us those 2 radii that we need. Now I'm going to start with my line, and I'm just going to start at 0, comma, and I'm going to go up to 0.75. Oops, I actually want to start at 0, comma, 0, enter, and then go 0, comma, 0.75. All right, so that looks good. And I'm just going to draw that line a little bit past. I'll trim that up then. And then I'm going to do my other line, which is at 3.75, comma, 0. And it's going to be 3.75, comma. Oh, actually, you know what? I don't need to. I can just draw it up past, and then I'll just trim it. And then I have a line that is at 0.5. So I'm just going to start this line at, we'll start this line just, I guess, just 0 in the x, comma, 0.5. And I'm just going to draw that farther than it needs to be. And then if you take a look here, so I just drew this line. Take a look here, this angled line meets, it looks like, we zoom in here, it looks like it meets right there, but it doesn't meet at, it actually meets at this radius. So this is actually showing a radius point, even though it's really hard to see there, there's a radius in here. So we need to draw that radius. So what we're going to do is at 0.75 in the y and this dimension minus this one. So I'm going to create that extra radius, and I just happened to forget that one the first time. Okay, so let me just go to my fast points, and we're going to go to 3.75 minus 1.858, comma 0.75 is the location of that radius. Oh, can't create it. Let's try that again. I must have typed something in wrong. 3.75 minus 1.858, comma 0.75. Enter. There we go. Yeah, I must have accidentally hit something wrong. 0.5. Enter. Okay. All right. So our next line, what I'm going to do is actually I'm going to trim some of this up just to kind of clean it up a little bit. So I'm going to pick my divide and get rid of that. What else did I want to get rid of here? Get rid of that. And we're going to create a line here. I'm just going to pick a tangent. And I'm going to make a tangent to that one there. So that looks pretty good. Then we're going to trim that. Going to trim this. Trim that. We do have to create a line that is going to be tangent to this one. So I'm going to make a line tangent. And I'm going to set an angle here because it says it's 140 from horizontal, which means that technically I would be drawing this one. This would be going, so if I'm looking at opposite interiors, let me pull this over so you can kind of take a look at it here. So basically I'd be drawing the angle that comes down from here. So essentially if this is 90, if I take 140 minus 90, I get 50. So it should be a negative 50 degrees here. And that should be, oh, check that. It actually should be a negative 40 degrees here. Let's move this around. Angle negative 40. Tab. Oops. Oh, we came off the wrong side. Let's trim this up before we go any further, just so we can get rid of that and not have to worry about that happening again. All right, line. And let's put in a negative 40. Point tab. Okay, and there we go. And we can trim this. All right, and that looks pretty good. So what we have there is our profile. The one thing we didn't add yet is this radius. That just needs to be added, and we need one there as well. Okay, so there is our profile. Now I'm just going to go ahead and hit the check mark. And if I go into, oh, I need to connect this first. Oops. Delete. Connect to that point. Okay, good. All right, so now if I go into surfaces and I go to my revolve, which I seem to be missing, there it is. It says select profile. So I'm going to go ahead and select this profile. Hit check. Enter. Axis of orientation. That's going to be this one. Now you can see it gives me this full 180 degree. Now of course I do not want that. I only want 100, or sorry, it gives me full 360 degree. I only want 180. So let's put in 180 and see what that gives us. Okay, so that's the opposite side. So we want to start at 180 and we want to go to 0. And that's going to give us the correct axis. Notice that my z-axis is pointing up, so I'm going to be able to machine the inside of this. All right, so I'm going to go ahead and hit check. And I'm actually going to grab that profile real quick and put that on a different level. And generally I create this, but I just forgot at the beginning. Okay, and let's go ahead and move that to, yes, check. All right, so now I can just get rid of that if I want it, and I can toggle it on and off. So I like that. All right, let's go ahead and hit top. I'm going to toggle this back on real quick. I'm going to turn my axes on, so I'm going to go view and show my axes just so I know where I'm at in three-dimensional space. And I'm actually going to move this part so that my 0, 0 is in my upper right-hand corner. So what I'm going to do is take a look at this print, and I need to shift it over in the X point 4375, and I need to shift it down in the Y 1.25 to get it to where I want it. So let's go ahead and do that. Let's go to transform, translate, and I'm going 0.4375, tab, and my Y is going to be negative 1.25, and I'm going to move this, not copy it. And I'm going to go ahead and hit check. Okay, so now my part is exactly where I want it. I'm going to toggle my profile back off. I can go in here and I can hit clear colors, so it goes back to my normal color. And now I'm going to go in and set up my stock. Obviously, to do that, I first need to select my machine. In this case, I'm just going to select the default machine. I have my default set so that it automatically gives me a 1 by 1 by 1 cube for stock. But I can go in here and I can edit that, obviously. So my y-axis needs to be 2.5. My x-axis needs to be 4.625. And I believe my z-axis needs to be 1 inch. Yes, it does. And my corner is going to be right up here. And I'm going to hit check. And there we go. So I have my stock set up. My part is ready to go. And we are ready to start creating toolpaths. So let's begin with these toolpaths. The first one we're going to start with is an OptiRough, and this is basically going to remove a bulk of the material. So if you think of this as kind of a pocket in here, we're going to remove most of that material. We're going to leave just a little bit on all those faces to come back and take a finish pass. So I'm going to go into there and I'm going to select my OptiRough. Actually, yeah, I'll select my OptiRough real quick. I'm going to show you another thing that this does here. Paint. So if we have a pocket and it looks maybe something like, make it really simple, it looks something like this, okay? And let's just say that's 1 inch deep. What our OptiRough will do is it will take step downs and then step ups. So it actually, like, let's say we can rough a full 1 inch out with our end mill. Our end mill has a 1 inch length of cut, or maybe a 1 1/4 length of cut. And let's say this is an inch from here to here. And this is kind of like a cross section of our pocket. So what it will do is our end mill will come down the whole way and it will rough out everything in here. So it'll rough all this material out. And then depending on what we put for our step up, it will step up. Let's say we put 100 thousandths in there. It will step up 100 thousandths and it will rough around the whole thing and it'll rough all that material out. And it'll keep stepping up 100 thousandths so that it only has to make perimeter cuts. So when it does these, it only needs to go around the perimeter one time and around the perimeter one time. Rather than if you think about it the other way, if we didn't step up and we roughed a ½ inch down at a time, it would have to, or sorry, like 100 thou down at a time, it would have to rough all this area, and then it would have to rough all this area, and then all this area. So it gets rid of material a lot quicker. It's a lot more efficient way of doing it because we get rid of all this in one pass, and then we can just do a perimeter, just a a pass around the perimeter, to get rid of all these 100,000 steps. So that's how it becomes more efficient. So let's go ahead and select this. So these, it's not obvious where you select your boundaries and your surfaces. So right here is where you're going to select your surfaces. So your machining geometry, we're going to want to select that and click this little arrow right here. And I'm going to click that, and I'm going to go ahead over, and I can either select these all manually, so I can select each one of these individually, but there's some that are small, and you have to zoom in to get them. So the easiest way is to use these selection methods over here that I showed you guys in Mastercam 1. We can just pick those, select all surface entities, bam, and I have them all. So that's perfect. So I'm going to hit End Selection, and I have 11 entities. That's perfect. Now, in here is where I'm going to select how much I want to leave on all of my surfaces. So for the wall stock, I usually select 0.01. I usually leave 10,000. So I think your book has you leave 20 on. That's fine too. There's nothing wrong with that. It just depends on how much you want to leave on. And I try to leave somewhere between 20 and 10 just because you don't want to leave too much where your tool's going to deflect when you're cutting it later. And you don't want to leave too little where it's not going to cut at all. It's just going to kind of rub. And you're going to end up with it'll actually leave like marks from where you were roughing it. So you don't want to do that. You want to have a nice clean surface created by your finish tool. Okay, so moving forward, I'm going to go to my toolpath control. Oh, and okay, so right here, if I look and I just hit include silhouette boundary, and I hit check, and I regen this path, it really doesn't know where to go. It needs a boundary in here. So what I'm going to do is I'm actually going to create, let me hit stay inside, and let me hit inside here, and let's regen that. So what it needs is a silhouette boundary. It needs to know where the boundary is in this thing. So what I'm going to do is I'm going to go to my levels, and I'm going to create my boundary. I'm just going to say boundary. And I'm going to create that by going to wireframe and hitting silhouette boundary. And I'm going to select all my surfaces again, hit end selection, and hit my check mark. And it will create a boundary around that surface. So now that I have that, I can go back into that toolpath. And normally I would want to do that beforehand. I just happened to forget. So I'm going to hit check. Check. Okay. So now that we've selected that, that looks good. I'm going to hit strategy. I want to stay inside of this pocket. I want to compensate to the inside. I don't want to compensate to the center or the outside, not for roughing anyway. We'll change that when we come to the finish. Include tool radius, yes. And skip pocket smaller than 0.55. Yeah, that's fine. We don't have to worry about that really. I'm going to select a 1/2 inch bull end mill with a 1/8 inch radius. This is going to give me a semi-nice finish. And I'm going to go with a feed rate of about, let's just say about 60,000 or 60 inches per minute. And of course our spindle speed is going to be 12,000. And I'm going to make my plunge rate, I'm going to make that 50 inches a minute because I'm going to helix in here so I can go pretty fast. And I'm going to rapid retract as well. I don't need the stock because I'm not doing any rest material. I want to climb mill, and everything here looks pretty good. By depth, that looks good. Okay, so my step over, how far I'm going to step over, I can change that depending on how deep of a cut I'm taking. So for this one, I think I'm going to take, I think I'm probably going to take 35% step over for this. And my step down, I'm going to take 50% of the cutter. So I only take a 1/4 inch. And I could easily take more than that. But just for this tutorial, I'm not going to take much more. I'm just going to take a 1/4 inch depth of cut. This isn't very deep, so I don't really need to go that deep. Step up. Now this is the step up that I'm talking about. So for this one here, I'm actually going to leave this at 10% and step up 50 thousandths so that it cleans. It's going to give me a smoother surface finish here. That way I have less to clean off when I do my finish pass. This minimum tool radius, this is fine. My back feed rate, this is, so if it goes and makes a cut, and then it has to circle around again to start the cut from the beginning so that it climb mills the whole time, this is what the speed that it's going to circle back with. So I can make this 500 because that's the max that the hottest post will allow. But I actually have a new post that will actually allow us to do 800 there. So basically, which is the max that the machine will allow. Okay, so let's go ahead. We don't need mill vertical walls on because we don't have really any vertical walls there. Let's move on to transitions. And okay, so in hand transitions, we are going to keep it on helix, and we're actually going to increase this to 0.25 for that helix. And let's see, plunge angle 2 degrees is good. Trying to think of what else I want to change there. Everything there looks pretty good, so that looks good. Steep shallow, we don't need that for this one. Linking parameters, I'm going to change this to 1 inch because we don't really need. I mean, I could even turn this off honestly. We're going to minimize the trimming here. No, we're going to actually change. We're going to minimize the trimming. We're going to machine the entire pass. We're going to minimize the trimming on our finished pass. And arc filter, yeah, we're going to change this up a little bit. So let's change our arc filter. We're going to change this in all axes so that we'll create arcs for us. And I'm going to make this 40% like it is in the book. And I'm going to make that 60. Minimum mark rate is 100% of the cutter. And everything in there looks good. Okay, so I'm going to go ahead and hit check. And we're going to regen this. And it should look pretty good. If it doesn't, we'll have to go back and check. But that looks like what I want to see there. So you can see here, if I zoom in, it's actually hard to, okay, so you kind of see here, if I don't select that. So you see the swirls here. That is that swirl pattern right there. That's the first depth cut. And then you can see down here we have another one. That's another depth cut. And I think there's one down here. And then each one of these solid lines are just a step over. They're the step ups. I'm sorry, they're the step ups. So that's what's cleaning up closer to the edges. Okay, so we have our path there. Let's go ahead and simulate that quick just to see how it looks. So it looks pretty good. Yeah, I can't complain about that. Got rid of most of the material. We stepped over, took most of it out. Now, you'll notice that it left a little more on here. That's because it can't get really can't get in there. And we're going to talk about that here when we go ahead and do our finish pass. So let's go and move into our finish pass. For this, we're going to use a hybrid method. Basically, the hybrid method allows us to split between flat surfaces and vertical surfaces. So it's good for transition surfaces, where you have something that's almost vertical to something that's basically almost flat, kind of like at the bottom of these arcs. So once again, I'm going to select all of my surfaces, and I'm not going to leave anything on the walls this time. Toolpath control, we are going to pick our silhouette boundary again. And tooltip. Okay, so we're going to contain the tooltip. We are going to go in center this time. So I want the tooltip to be right at the center, on center when it goes around this line. Tool, I'm going to pick a 3/8 ball mill. Now, I know that your book has you pick a 1/2 inch. There is a very specific reason why I am using a 3/8 end mill. And that is because all the radii in the corners are 1/4 inch. So when you go to pick, or when it goes in here to cut this, it's going to be engaging more than 90% of cutter in this, 90 degrees of the cutter. So basically 1/4 or more of the cutter in this corner and in this corner. You're going to end up with chatter. So you don't really want to do that. I always like to pick a size smaller ball mill for my finish than what my minimum radius is. And you should do that as well. My feed rate, I'm gonna pick 100 inches a minute for this, because remember, I'm not cutting anything. I only have 20 thousandths on there. So I'm not cutting a lot. Obviously, this is max, we're in aluminum. My plunge rate, I could do that at 30 inches a minute. Stock, we don't need that. Okay, so we want to make sure we climb mill around this whole thing. I want to optimize the cut order. Our Z step down. I believe in your book it's using 10 thousandths, and I'm going to follow that. This is what's going to control how good your finish is. So it's also going to control how long it takes to regenerate the toolpath and how long it takes to machine. If your Z step down is 10 thousandths, that means it's 10 thousandths between step overs, or step downs, I should say, in this one, because the hybrid toolpath separates step downs from step overs. So we're going to step down 10 thousandths, and that'll be fine. The limiting angle, this is the angle with which it uses to limit the difference between step down and step over. So I can control the step overs on these flat surfaces separate with a 3D step over from the vertical Z step down. And the delineation point is right here. I control that as well. So I'm going to make that 45 degrees. And I know your book has you do a different step over for this, but I'm actually going to keep that at 0.01. I like it to be consistent. So we're going to go ahead and do that as 10,000 as well. It's fine. If you put the book's numbers in for any of this stuff, that's absolutely fine. That's pretty much what you should be doing. But I'm just kind of going through it and showing you the differences and why I might change things around a little bit. Okay, so our 3D passes, we're going to use a closed offsets like your book does. Basically, that just means it's going to see this as its own boundary, or its own chain, I guess. And everything there looks pretty good. And I'm going to go into some of this stuff, these other things that we're not using, a little bit later in other tutorials. Okay, so we're going to tangent ramp. Steep shallow, we don't need that on. Our linking parameters, we'll just change this to 1.0. We are going to minimize the trimming on this one, and we're going to keep the full vertical retract on. Our arc filter. We're going to turn on our arc filter, and we're going to use XZ and YZ as well. Basically, what this does is it tells the Mastercam post what we want to turn into arcs and what we want to use tiny little line segments for. So basically here, if I turn on smoothing as well, I'm going to make the tolerance 33.0, and I'm going to basically follow exactly what your book did, and I'm going to use 33 for this one, 0.0. And there we go. And you have to fill these out left or right, or you'll never be able to get these exact divisions. Okay, for this here, the minimum arc radius, this basically means anywhere on here, the minimum radius that it's going to create, the minimum G3 or G2 code it's going to post is going to be 0.1 in this case. So it won't post an arc smaller than that. Anything smaller than that, it'll just post as small little line segments. And everything else there looks good. Okay. So let's go ahead and hit check, and let's see what we get there. And you can see here, this means it's regenerating. These take a while. So try not to get impatient, start clicking around like a madman, because it will eventually regenerate depending on how fast your computer is. One thing I wanted to note, you'll see that these look like they're coming through. That's just because this is a surface and it's infinitely thin. So they're not, that is fine if you see your toolpath through the bottom of here. It's okay, especially if you're using a surface. If you're using a solid that's coming through the bottom, you got a problem. But surface, you're good to go. All right, so I'm going to select those, and let's go ahead and preview it. You can see there's our finish pass. It's cutting it all out pretty smooth. Okay, so take a look, and you can see our surface finish looks pretty good. It's only as accurate as the graphics, obviously, but it does try to represent what it would look like. You can see the passes there. It look like ball mill passes all the way around. Yeah, it looks pretty darn good. One thing I do want to show you before we end this video is I want to show you what this looks like if it's changed. 0.0, what was it? I think they did 0.02 in the book. So it's basically double. So let's regen that. And of course it'll take a second here. And let's see what that surface finish, see if it looks the same. Or see how much different it looks, I guess, if at all. It's not a big change, so it might not make too big of a difference, if at all. Ah, yeah, it does make a difference. So you can see now how coarse the step over is down there compared to up here, right? It's pretty obvious, actually. So that's the difference that it makes if you don't have a consistent step over. It will definitely affect your finish. But there's a happy medium there. The closer you make that, or the smaller you make that number, the longer this thing is going to take to simulate. So right now, I'm not sure what our last one simulated at. Let's take a second here, and we can actually see over here. It looks like this is going to take a total of 12 minutes to machine. And of course, that's not realistic or accurate in the real world, but by comparison to the other one, it will be. So you can see that the finish is much better. So this is 12 minutes to machine. We got a nicer finish, but if we go back and we change that back, 0.02, and regen that, we select and we, went back plot. And so it only took a minute off for this one because it was not a huge deal. But for bigger parts and stuff like that, this could change by as much as, double, really, pretty close to double. So it just depends on, what you're doing and the part you're doing. But it only changed by about a minute. So I think it's definitely worth the smoother finish in this case. At any rate, that is all I have for this tutorial. Of course, as always, you can ask me questions during class or in my office hours.